through each question and kind of go through the whole unit really quickly to see the general questions and sections so you can see where you're at. Here we go. So our first lesson, we looked at types of numbers. So that was things like real numbers, rational, irrational, whole numbers, integers, and natural numbers. So we had all these types of numbers, if you remember. So here's a question. What is negative 5.22? Which ones of these is it? Well, negative 5.22, you can see, is a real number because every number we know of is real. Is it rational? What does rational mean? It means you can put it in a fraction form. Can we put this in a fraction? We can, because it's terminating. So this one is irrational. If something is rational, it can't be irrational. So we're going to put that. Irrational numbers are like pi, or ones that don't terminate and seem random. Is it a whole number? No, it has a decimal and numbers after, so it's not. Is it an integer? No, because of the decimal as well. Is it a natural number? No, it's not even positive, so it's not. So it's just those two. All right, so now we go to this one. We have a radical sign, so it's not so easy just to put them in, so we have to simplify it a bit to see if we can classify it. So here we can go negative 6 because root 36 is 6. So we converted all of that just to the 6, so it's negative 6. So it's real, it's rational, because it doesn't go forever. It's whole, or it's not whole. It's not because it's negative. That's the only reason. But it is an integer as well. So those are the three classifications of negative root 36, because we know it's the same as negative 6. So that was our first section that we went through. And then we moved on to something called mixed radicals, which was the second section out of 5. So we have to simplify this number here. We have to see if we can get it more simple by putting it into a mixed radical. An example of a mixed radical is that where you have a number out front in front of the radical multiplying the radical. So this one we want to try to group this out so that we can do that. So here if we look 144, the first step in these problems is to prime factor it. So 144, we can prime factor. I know 12 times 12 is 144. 4 times 3 is 12. 4 times 4 is 2 and 2. 2 and 2. We take the branches of each, and then we know 144 is really just the branches. 2 times 2 times 2 times 2 times 3 times 3. Okay, so that's the prime factorization. Now I'm going to write that 144 as that number, but I still need that radical symbol with the index of 3. So it's 2 times 2 times 2 times 2 times 3 times 3. So we have that. And then our goal now is see if we can take anything out and put it in front of the radical, because we want a mixed radical. So what we're going to do here is we look at the index. We need to take 3, group them into groups of 3 if we want to take any out. So we know that there's at least 3 2's, so we can group those. There's only 1 2 left over, and only 2 3's left over. So we can't group anything else. We can only group those 3. So we're going to take those out, and we'll be left with 1 2, because you convert the 3 into just 1. And then we have 2 times 3 times 3, and this will give us 2 cube root 18. So we simplified it, or we put it into a mixed radical. We just changed the form into 2 cube root 18. All right, so this next one we have to do the opposite. We have to put it into a mixed radical back into a whole radical form where there's no number out front. So we're going to do the same process but backwards. So that's a 5 there. That's the index. So we want to put that 4 back on the inside. So if we want to do that, that means we have to make one 4 into 5 4s. So 4 times 4 times 4 times 4 times 4. And then we still have that 12, so we need that in there as well. So that's pretty much our answer there. We just have to use the calculator to bring it into the big form. So we can go 4 times 4 times 4 times 4 times 4 times 12. So we have 12, 2, 8, 8. So we have the fifth root of 12,288 is the same thing as 4 times the fifth root of 12. We just put it in a different form. So that was chapter 2. That was our second section of this unit. Now if we go to the third section, fractional exponents, this is when we now have put fractions in our exponents, and we're trying to understand them a little bit better. So our first sample question is x to the 5 times x to the 7. If you have the same base, then you can add the exponents if you're multiplying the bases. Okay, so this we can go x 5 plus 7 is equal to x to the 12. So x to the power 5 times x to the power 7 is the same as x to the power 12. Alright, this next one, we have the same base, we always have to check that, so we can do something. This is not, the bases are not necessarily being times like this question, they're being divided. That's what that big symbol is, divided. So it's 5 cubed divided by 5 squared. So what we do here is we'll put the same base and we'll just subtract the two numbers here. So 3 minus 2. And that'll give us 5 to the power 1, which is just 5. Alright. So our next one here, we have a to the negative 5 to the power to the negative 3. We haven't even done negatives yet. We're only on the third section. But at this point, we can use these laws. If you have brackets here, then what you can do with the double exponent is you can multiply them together. So we can go a negative 5 times negative 3 is positive 15. So this is really the same as that. Alright, now we're on to this one. We have brackets again. We kind of have an exponent to an exponent, and we also have something down here. So when you have multiple things in the bracket, not just one base and exponent, but you have multiple bases and multiple exponents, you have to distribute this one on the outside. So this one can go in and in. And it multiplies this exponent and this exponent, which is 1. If it's not shown, it's 1. So what we end up getting is x 3 times 2 is 6 over y 1 times 2 is 2. So then you might say, oh, now we can go 6 minus 2, but you can't do that. Why not? Because the bases are not the same there. X and y are different, so that's our answer. That's the simplest version of this thing here. Okay, now we go on to a radical. We have 27 to the power 1 over 3. That's a fraction now, so it's a bit different. It says it wants it as a radical. So we know the top number goes to the exponent, and the bottom number goes as the index of the radical. So that's our answer there. We know 1 can just not be shown, so it's just the cube root of 27. And what does that mean? It means what number times itself equals 27. Or what number times itself 3 times will give you 27. So we know that 3 times 3 times 3 equals 27. So we know the cube root of 27 is just 3. Another way to do that part is if we were back at the cube root of 27, you could prime factor 27, which is 3 times 9, and 9 is 3 times 3. So then you group them, and we know cube root is 3 times 3 times 3, and then you can group the 3 out. Okay, but we know our answer is just 3. All right, now we have 9 over 16 to the power of 3 over 2. Just like this other one over here, we have to distribute this in because there's 2 different bases at least and only 1 exponent. So this has to go to the 9, this whole 3 over 2, and it also has to go to the 16. So what does this equal? It's equal to 9 and 3 over 2 and 16 and 3 over 2. So that's the same thing. We know we're allowed to do that. And now the next step is see if we can simplify it some more. We know we can't subtract them because they're not the same bases. So what else can we do? We can change it to a radical to see if we can do anything with that. It's a bit cramped here. So we know it's the square root of 9 cubed all over the square root of 16 cubed. Alright. And if we get there, we know we can't do 9 cubed in our head. So it doesn't matter which order you do it in. You can square root or you can cube first. Let's square root it because we know 9 square rooted is just 3. So that's going to be the same 3. We didn't do anything with the cube, so it's still there. And then the 16, we can't cube it, so let's square root it, is 4 cubed. And then overall, we can kind of do that in our head. 3 times 3 times 3 is 27. And 4 times 4 times 4 is 64. So this whole thing can be simplified to that. Alright. So this one I had to change a bit. This is a 2 right there, and this is a 3. So how do you write this as an exponent? This radical as an exponent. We know the base is 25. We know the index is 2, so that'll go on the bottom of the fraction. And then we know the cubed is on the top. So that's as an exponent right there. One thing to notice as well is you could have simplified this because 25 square rooted is 5, and you keep the 3. So 5 cubed is 125. Okay, but this is writing it as an exponent. Now last of all in this section is sometimes they ask you to do certain things with no calculator. So 32 to the power 1.4, which seems very abstract, we have to look at. So we know that we want to bring this to a fraction because we know what to do with fractions, not decimals. So what is 1.4 as a fraction? Well, we know 1.4 is 1.4 over 1, and if we times the top and the bottom by 10, it's the same as 14 over 10. So we know that this 1.4 we can write 14 over 10 to get rid of a decimal place. So it's 32 and 14 over 10. We can simplify the fraction because we notice that 2 goes into 14 and 10 to give us 7 over 5. Alright, so now if we write this as a radical, we can go the 5th root of 32 to the power 7, because that always goes as the index, that goes as the exponent. And this will give us one thing I notice is we can prime factor 32 to 2 times 2 times 2 times 2 times 2. But that 7 still will be there. Okay, so we can group all those 2's out and we can bring them on the outside. So this is a really tough question. So we can take all the 2's and bring it on the outside. And now we're left with a 5th root. What's left? Just a 1 with a 7. Okay, 5th root of 1 is just 1. And 1 times 1 times 1 times 1 times 1 times 1 times 1 is just 1. So we're left with